Hello everybody! In this lesson, I will help you with your June exam preparation. I will also discuss question 10 of the 2021 paper. From the CAPS document, it's very clear that calculus is a huge section, 23% of your paper. Now in this question, I will discuss the calculus function or the cubic graph. Now you will see at the end of the lesson, I added the playlist on calculus. Now there you will find all the lessons on the graphs. And now I suggest you watch them. First, I will teach you how to sketch the basic cubic function, and then I move over to more difficult ones, and then I will teach you a very important concept, and that is where you will find or how to find the equation of the cubic function. But let's move on to this question. Here you find the question. I suggest that you pause the video, quickly do the question, and then come back to the explanation. The graph of h of x is ax to the 3 plus bx squared is drawn. The graph has turning points at the origin and at b 432. A is an x-intercept of h. 10.1 show that A is -1 and B is 6. Now we are going to zoom in on the fact that B 432 is a turning point and it is a point on the graph. Our aim is to do simultaneous equations. So where do we get the equations from? There is the original equation. And then, do you agree, a turning point is a local maximum or minimum, and that is when we find the derivative, and we're going to equate it to 0 just now because it's maximum minimum. But let me just explain how I got the derivative. Was you take the exponent, it moves to the front, and you subtract 1. Again, take this 2, moves to the front, subtract 1. Then we're going to inside the derivative, which is the turning point. In x's place, we are going to substitute the x coordinate of the turning point, and y equal to 0 is because it's a local maximum. I did it for you, and then in x's place you substitute the 4. 4 squared is 16, and then 3 times 16 is the 48, and then 2 times 4 is 8. Then you can divide right through by 8, and you end with 6a plus b is 0. And then what I did was I made b the subject of the formula, and you call that one equation 1. So now you dealt with that point B as a turning point. Now I'm going to deal with it as just a normal point on any graph. So into the original equation now, I'm going to substitute the point 432, which consists of an x and a y. And this is the correct notation. This means in x's place in h, I'm going to substitute 4 and equate it to y. And then I did it for you there. And then 4 to the 3 is 64, and 4 squared is 16. And then I could divide right through by 16. I got that. And then since I got in this equation b alone, I made b the subject of the formula, I'm going to do it here as well. So b is -4a plus 2, and I label it number 2. So u are equal to b, u are equal to b, therefore the two of you can be equated. So I equated the two equations, and now I'm just going to solve for a by bringing this a across, and I'm happy. A is -1, that's what they wanted. And then to find B, I'm going to substitute A into number 1. You can do it into number 1 or number 2, but number 1 looks easier for me. So into A's place, the A that I just calculated, -1, and then B is equal to 6. And then where's the marks? The marks are for finding the derivative, and equating it to 0, the substitution of the 4, the substitution into the original equation, and then 1 mark for finding A and B. 10.2, calculate the coordinates of A. So what is happening? A is there, this is your x-intercept. So now, remember your equation that was given to you was ax to the 3 plus bx squared. And in the previous example, we worked out that the a is -1 and the b 6. So whatever values you got, if you didn't get these values, please don't use your values. You use their values. All right, so what is happening? A is x-intercept. The rule is x-intercept make y 0. So where's the y? The y is in fact this h of x. So into y's place, I made it 0. And then I divide it right through by minus because I want to factorize, and you cannot factorize if there's a negative in front of x to the 3. And then when you factorize, I took out x squared as a common factor, and then x squared is 0, or x minus 6 is 0, and then x is 6. I'm not so interested in this point over there because I already know that that point 0, 0 was the other x-intercept and the turning point. I'm interested in the point x is equal to 6, but you cannot stop there because they specifically asked for the coordinates of A, so you have to write this in coordinate form. And then where's the marks? The marks are there, equating everything to 0, the factors, and A in coordinate form. 10.3. Write down the values of x for which h is increasing. So h is increasing from 0 up to your turning point over there. So from 0 to 4, the x of the turning point. And how do you write it in maths? You can either write it like that, or you can use interval notation. And then where's the marks? The marks are for the two critical values, meaning 0 and 4, and then for writing it like that. Any of the 4 answers, they will award you 2 marks. Now, at number 10.3.2, the concave down part. Now, when we look at concavity in a graph, we're looking at the point of inflection. So what is that? The point of inflection is where the concavity of the function changes. A cubic function can change from being concave down, a sad or convex face, to concave up, a happy face. The point of inflection is in the middle of the two turning points. So there, that is where you find your point of inflection. And it is calculated by finding the second derivative. So what is that? First of all, there's h of x. Your first derivative, you already calculated that. And then the second derivative you get by finding the derivative of the first one. So you will find the derivative twice, you equate it to 0, and you work it out, and you see that x is equal to 2. So the point of inflection is x is equal to 2. But if you look at your graph, I said that the point of inflection, the x value, is right in the middle between the two turning points. So yes, this is fine. Now what is this now? This side of your graph over there, can you see that this forms a happy smiley face? So that you call concave up. And then from 2 going that way, can you see it's a sad face? and then this one, your graph is concave down. So what's the answer? From the point of inflection going that way, and you write it as x is greater than 2. Or you can write it as x is an element 2 up to infinity. And where's the marks for the point 2 and for either writing it like that or that? On 10.4, for which values of k will that minus k equals 0 have one negative and two distinctive positive roots? So k is a y-intercept. So what you do, can you remember your original equation used to be h of x is minus x to the 3 plus 6x squared. And now, suddenly, in x's place, there's x minus 1. So what I did here was I'm finding a new equation, f of x, and in x's place, I'm substituting x minus 1. And then, since k is a y-intercept, I'm going to make the x 0. So in x's place, I substitute 0, and I find that the y-intercept is 7. And then what you do is, the y-intercept is 7. So then your answer will lie between the y-coordinate of the turning point and your new y-intercept. So it's between those 2 points. And how do you write that in maths? You write it as k is smaller than 32, or k is greater than 7, or you can write it in interval notation. As promised, you will find the playlist on calculus, and then I also added the playlist on the factor remainder theorem. I suggest that you also watch that playlist. And then in the left hand corner, if you click on that video, that's the next question of this paper, question 11.